So this one's also going to build up on what you kind of already know. So how do mass and kVp affect quantity and quality of your X-rays? So you might remember that mass really only affects quantity, or the number of X-rays produced. So if we were to think about this in terms of the spectrum, what do you think might happen? Well, we know that mass has nothing to do with where our start point and our end point will be along this axis here, because this is energy level. This is kVp related down here. So that's not going to change. Neither will the peak of this curve here either, because that happens at about 1/3 of our kVp, which didn't change. So the only thing that happens is amplitude here. If we have 200 MA, well, then we have a number of X-rays produced. Here is the peak. If we were to double our MA, our mass up to 400 MA, then we're going to get a double, an increase or a doubling of our peak here. But along this axis down here, nothing changed. Only along this axis up here. It went from this point up to this point. On the other hand, we have kVp. Now we know kVp affects quality and quantity. So how will this affect the spectrum? Well, if we have a change in kVp, well then yes, we will have a change of where this bell curve starts and also stops. Here our kVp selected was 72, so it stops here at 72. Or here we have 82 kVp, so our continuous spectrum goes all the way to 82. And what that means is we will also change amplitude, because we're also changing the quantity of X-rays we get, but also that affects where this peak is. So the peak of this curve for 72 kVp will be at 1/3 of 72. Here it looks like it's at about maybe 27. I'm not doing the math very well, but and then over here for 82 kVp, we'll get a peak at about 30, almost. Again, my math isn't very good right now, but 1/3 of 82 is where our peak is right here. So we can see we have a change in amplitude and also a shift of things along this axis as well. Notice how, though, our K characteristic line never changed. It won't change because we have we still have tungsten. Very specific line, always stays right here along this level, although the number of X-rays might change, but it never moves along this x-axis. So how do filtration and target material affect quantity and quality? Well, if we add filtration, what we end up doing is increasing the overall energy of our X-ray beam. We call this hardening the beam. Overall, the energy level is higher because we are removing those lower energy X-rays. What that means on our emission spectrum is we still start and stop at a certain kVp. We weren't changing that. But now we do have a difference of where this peak is. So if we only have 2 millimeters of aluminum added, we can see our peak is here, right at about 30. But if we harden the beam, we add more filtration and make the overall energy of our X-rays higher, we can see that now we've started to affect where this peak is. And it's closer to, let's see, 45, maybe 40. Now, target material, that is finally where we get a shift in these lines that we've been seeing, these discrete spectrums. Because we aren't only using tungsten anymore. Here we see gold, molybdenum. That's going to affect where these discrete lines are because they each have different energies holding that K-shell electron close to the nucleus. So those start to change, as well as our amplitudes here, or the number of X-rays we'll get based on those atoms. Finally, also, our equipment will change these bell curves here. We can see that with a high frequency system, We get our bell curve at around here, again 1/3 kVp generally, and we get the highest amount of X-rays produced. With three-phase, things get a little bit less, and single-phase, we see quite a decrease in energy and X-ray efficiency. This table came straight from your book. It's a really useful one to remind you of what mass does to quantity and quality, and then from there you can decide what it might look like on your emission spectrum.